Hi everyone, I'm Sharmila from Can Do Teach, and in this video we're going to be looking at basic quadratic factorization. So factorization is basically the reverse of expansion. So before we get into it, I just want to go over expansion for those of you who haven't done it for a while. So if we have something like x times x plus 2, when we expand it, we just multiply everything that's outside the bracket by everything that's inside the bracket. That's called the distributive law of multiplication. So we say that x times x is x squared, and x times 2 is 2x. So that's it, that's expanded. So to reverse the process, if we wanted to factorize this thing, we just look at x squared plus 2x, and we say, what's the common factor between the two terms? And so we can see that both of these terms have an x in it, so we can take that outside the brackets, and then what's left is the x from the x squared and the 2 from the 2x. So that's factorization when we have a common factor. But what if we have to expand something more complicated? So if we have two binomial terms multiplying each other, let's say x plus 1 and x plus 2. So you might remember the FOIL method, where we go first, outside, inside, last. So the first times the first is x squared. The outside, x times 2 is 2x. Inside, 1 times x is x. And last is 1 times 2, 2. So first, outside, inside, last gives us this, and then we can combine these two because they're like terms. So that gives us, write it down here, x squared plus 3x plus 2. So that's how we expand two brackets, but we can see that it's not that easy to factorize because we don't have any common factors anymore. So we're going to look at now how to factorize something that looks like this, which we call a quadratic trinomial. Okay, so we've got this example here, something that we need to factorize. And we know from the expansion that we just saw that we can probably get it into something that looks like x plus something times x plus something. Okay, so you need to know what these two things are, which we don't know yet. So I'm just going to start by calling them m and n. And now I'm going to see what happens if I expand this, so I can try and match it up with these numbers here. So x plus m times x plus n gives me first x squared, outside x times n or nx, inside m times x, and last is m times n. So that's the expansion, but I can see that those two are like terms, so I'm going to factorize the x out of them. And so I'll have n plus m times x plus mn. So this is basically in the form that I have up here, x squared plus 5x plus 6, where the 6 is equal to m times n, and the 5 is equal to m plus n. So you can see that whichever two numbers I have here, the product of them is going to be the number here, and the sum of them is going to be the number here. So the sum is the coefficient of x, so the number that multiplies the x term, and the product, multiplication, is the constant term. So I need to find two numbers, m and n, that multiply to give 6 and add to give 5. So let's think about factors of 6. We've got 1 and 6, which multiply to give 6, but they add to give 7, so that doesn't work. But 2 and 3 also multiply to give 6, and they add to give 5. So that works. So we can say that x squared plus 5x plus 6 is equal to x plus 2 and x plus 3. Okay? And we'll just check by expansion that this is correct. You can always do this. X plus 2 times x plus 3, x squared plus 3x plus 2x plus 6 is x squared plus 5x plus 6, which is exactly right. That's exactly what we started with. Okay, so that's our general trick for factorizing a quadratic trinomial. You have to find two numbers that multiply to give the last term and add to give the coefficient of the x. Okay, so something to note here is that this only works when a, the number in front of the x squared, is 1. So when we don't have anything in front of the x squared. In the next video, we'll be looking at what happens when there is a number in front of the x squared, and that's called a non-monic quadratic. So we'll be looking at that in the next video. But for the moment, let's practice a few more monic quadratics, which are these ones right here. Okay, so factorize x squared plus 10x plus 21. So we're looking for two numbers that multiply to give 21, the number here, and that add to give 10, the number here. So let's think about what numbers would work there. Factors of 21 could be 7 and 3. So 7 and 3 do add to 10, so that will work. 7, 3. And they're both positive numbers, positive 7 and positive 3. So I can just put those in here. X plus 7, x plus 3. And that's it, that's factorized. So in the next example, we'll see an example where everything isn't just positive. So this time we have x squared minus 12 plus 20. So we want to find two numbers that multiply to give this number. And note that that's a positive number. And two numbers that add to give this number, which is a negative 12. Okay? So this time, if we have two things multiplying to give a positive and adding to give a negative, then they have to both be negative, okay? Because I can get a product that's positive by either multiplying a positive and a positive, or a negative and a negative. But if I'm adding two numbers to get a negative, it has to be a negative plus a negative. Okay? So I'm thinking of two negative numbers that add to negative 12 and multiply to positive 20. So see if you can think of those. They're negative 2 and negative 10. Negative 2 times negative 10 is equal to positive 20, and negative 2 plus negative 10 is equal to negative 12. So I can put my numbers with their signs in here. X minus 2, x minus 10. So just remember that the signs come from the numbers. So if the numbers are all positive, then it's just x plus, but if the numbers are negative, then it becomes x plus the negative or just x minus the number. Okay, so let's try another example. So this time we have x squared minus 3x minus 18. So we want to have two things that multiply to give negative 18 and that add to give -3. So let's think to ourselves, if we're getting a negative product, that means I must have one positive and one negative, because mixed means negative. So a positive times a negative will give me a negative. So let's try something like 9 and -2. Okay, so if I've got 9 and -2, it's not going to give me -3, it's going to give me -7, which doesn't, +7, which doesn't work. So both the positive and the number are wrong. So looking at this, if these two numbers give me 7, that's actually not the sum, but the difference between the numbers. It's the sum of 9 and -2. So what I'm actually looking for here are numbers that will have a difference of 3, and then if I make the bigger one negative, then I'll get a sum of -3. Does that make sense? So let's try for 18, 6 and 3. So 6 times 3 is 18, and I'll make the 6 negative because -6 plus 3 will be -3. If I'd made the 3 negative instead, I would have had 6 plus -3, so I would have had a +3 here, which is the wrong sign. Okay, so if the product is negative, then you've got a positive and a negative, and if the sum is also negative, then you want the bigger number to be the negative number. So in this case, I get x plus 3, x minus 6. Okay, so finally, we've got an example where we actually have to solve the equation. So to solve a quadratic equation, I'm looking for the x values that make this equation true. Okay, so that's really hard to do off the top of my head, but if I factorize it, it becomes much easier. So let's start by factorizing it. We want two numbers that multiply to give 40 and add to give -13. So I'm going to try and do this part in my head. You can write it down if you need to. But it's positive and the sum is negative. So I'm going to have two negative numbers that multiply to give 40 and add to give -13. So I know that 40 has factors 5 and 8, and they add up to 13. So if I make them both negative, x minus 5, x plus 8, x minus 8, then when those two add, they'll give -13, and when they multiply, they'll give +40. So you can expand that out to check if you're not sure. So now that I've got it in this form, it's basically the same equation, but now I can remember my null factor law to solve for x. So I can say that if this equals 0, then either this equals 0 or this equals 0. So if x minus 5 is equal to 0, then x is equal to 5. Or if x minus 8 is equal to 0, then x is equal to 8. Therefore, x can be equal to either 5 or 8, and it's solved. So that's how you do monic factorization and use it to solve quadratic equations. So you should practice this kind of factorization a lot so that you can do all of these steps in your head. And this is where practicing your timetables comes in handy, because you'll be able to think of the right factors really fast. Okay, so that's it for this video. If you have any questions, please ask them in the comments below. And if you need any extra help, you can always find it at candoteach.com. So have fun practicing these, and I'll see you next time. Bye for now.